games directly on the blockchain. We think that's the next generation of video games. Right, so I think the first question we need to answer is why make games on the blockchain at all, right? We play a bunch of video games and blockchain is a slow, expensive machine. Why do you want to make games on the blockchain? I think that there are a couple of principles that we have conviction in. We think blockchain is a wonderful place for composable creations, and for all DeFi users and creators who know what composability means. It's a wonderful place for interoperable platforms, right? So things that work in platform 1 can also work in platform 2. It's not a walled garden, the meta and so on. It's an engine for collaboration and for coordination. And the advocates of DAOs, although they're kind of rudimentary, I think that's along the direction of a future where massive amount of people and participants collaborate and build things together and coordinate. Right? So blockchain is a wonderful place for this. And accomplishing all these with the guarantee of immutability. Right? So if you write a program and deploy on a blockchain, you know no one can change it, right? Unless they change yours or something. So. But then why StarkNet, right? The topic today is why build games on StarkNet. So simple example maybe, I think it's important to explain what Stark is. So what does Stark, the moon map of Stark enable? And please explain like why. Okay, so the Fibonacci sequence. Imagine the 10 millionth term of the Fibonacci sequence. Right? It's an insanely huge number, right? In fact, the number is roughly like 1.13 times 10 to the power of 2 million, right? So it's a super long number. And if I tell you, okay, this insanely long number is the right answer, and you don't trust me, how do you verify that's the right answer? And this is the gist of the problem, right? I do a bunch of things, I tell you the result, and you don't trust me, so how do you verify it? So Fibonacci sequence is basically just addition, right? So 1 plus 1, 2, 3, 5, 8, and you do this for 10 million times, you get a large number at the end. It takes 10 million steps, obviously, to compute, right? 10 million additions. So how do you verify it? Basically, what Stark enables is it enables polyglot verification. So you're doing 10 million steps to compute, but it takes roughly 49 steps to verify. 49 is basically log 10 million squares. That gives you 49. Right? So it's insanely amount of scalability, right? I can do a bunch of computation, but the verification complexity is only polyglot. That's wonderful. And also it achieves completeness. So completeness basically means if I do not lie, then 100% will verify to make sure it's right. So it's like 100% passability if the answer is correct. Now soundness means that if I lie, then you will catch it. That's basically what soundness means. And it has the probability around like 2 to the minus 80, right? So that's a tiny probability that if I lie, I still get to pass verification, which is kind of negligible. So that's why the Stark method is black magic. All right, so given this, I think that I think that a wonderful mental model that I have, which is kind of oversimplifying everything, is that I tend to think of Ethereum as like a hard drive, right? So DDR4, and I tend to think of StarkNet or these CK rollups with their exotic CPUs like SRAM. Right? So we've been building applications with hard drive, right? It's pretty masochistic, right? We're just shooting ourselves in the foot while doing these things on slow machines. Now we have SRAM, we have cache, we have all these wonderful compute resources. So we should be moving to layer 2 and build more stuff instead of being masochistic and stay on layer 1, if that makes sense. Right. This another mental model I have is that I tend to think of the ecosystem as this multi-layered system. And so starting from the bottom, you have this hardware acceleration. That's what people talk about. ASICs or FPGAs for coolers. That's acceleration via hardware. On top of that, you have the operating system. So StarkNet is essentially an operating system, right? It controls who writes to what, when, that's allowed, and the sequence of transactions and so on. That's an operating system kind of job. On top of that, you have the ZK stack, the black magic stuff, right? So you have proof generation and verification. On top of that, you have arithmetization. That basically means transforming a computer program into something that can be verified. So that's arithmetization. Programming language basically means Cairo and its associated compiler that allows you to write stuff that can be verified. And on top is the exciting stuff. It's like where the application sits, right? So you use Cairo and these programming language to write low-level libraries, and then you build infrastructure on top, and finally you build applications and front ends on the very top. reason why we put on StarkNet is because Starkware takes care of the low-level infrastructure so that we can focus on the high-level application. It takes care of, basically Starkware invented Stark. Right? They're the cryptographers in Israel that are the inventors of all the mathematical theories here. And so it's a wonderful foundation to be built to build application on top. Right, so just to repeat, they are the inventor of Stark. They have a wonderful developer-focused culture, and I think Ben didn't mention the tokenomics that they're releasing. I think in their tokenomics there's a developer incentive. Right? So imagine a blockchain where fees accrue to smart contracts that are generating most fees. It's like if I make a low-level smart contract library where a bunch of other applications use and call my contract, then I get to receive fees as incentive from the blockchain, underlying blockchain. That basically encourages people to build more libraries that can be reused by applications. And if there's one library that's more expensive than the other library, while providing the same utility, then applications will migrate to the other utility with lower fees, right? So it's actually an incentive to sort of incubate a public good system. Yeah, and I think the last one is there's just a wonderful library of non-skeuomorphic ideas. And by non-skeuomorphism, I think that as we are making video games on the blockchain, there's a lot of wisdom in the game industry that we need to think carefully, because blockchain is a very different kind of place to build. And so a lot of these game mechanics and wisdom in the game industry doesn't really apply to the blockchain space. This mental model that I have is, I think video games we have now is like game 1.0. It's kind of like web 1.0, right? And web 1.0 is classified as something that very few people write to, most people just read, right? That's web 1.0, right? And web 2.0 is, we kind of all hate web 2, but web 2 is actually magic, where people get to contribute content directly and contents are interlinking and all interconnected, right? I think that game still is at game 1.0. We haven't progressed to game 2.0 yet. One evidence would be, this is the statistic in the US, I think 2 years ago. The number of game industry employees versus the number of US gamers is roughly 1 to 1,000. Right? So most people play video games. When you think of gamers as a persona, there are people that consume logic programmed by the developers. They don't contribute logic. Right? And I can make a couple examples with games. These are the popular video games. So like Fortnite, right? If you build this fortress, you're essentially using the logic developed by Epic Games to instantly deploy a huge castle and with all the bouncy stuff. That's Guilty Gear. So when you are using a specials, all the computer logic and the parameters that define where the hitbox is, the velocity of the special, how many frames do you need to start up versus active versus recovery from the special. All those are provided by the game developer. You're just pushing some combo keys and triggering that logic, right? This is Ghost Recon, that is Witcher 3. All these are examples that game developers put a bunch of creativity into these logic, and we are just consuming them by pressing keys and looking at the results. That makes sense. So we think that as we are building Game 2.0, we are going to be transitioning into an era where more people are actively creating things and programming things in these next generation of video games. There's more involvement of long-term memory versus the fast muscle towards short-term memory thing, which all esports games basically encourage people to be, excelling at fast thinking, muscle memory, and so on. That's not really inclusive. A bunch of people are not that fast reactive. But when we transition to a different era where most people can take time to invent things and push things into the core game system and expanding the games together, that's a different story. So I think we're progressing to Game 2.0, and can be understood as this borderless evolutions of core games. So we are not just consuming the game logic anymore. We are participating in the evolution of the underlying core systems. Right? So you're expanding the physics, you're expanding the AI, and so on. One thing that's very important is composability. So composability is something that's actually quite simple to understand. Right? It's like if you think about writing a research paper and you have this huge topic that you don't know how to break it down. If you can't break things down, you can't tackle it. Right? So you have to, when you have a big problem, you have to think about, can I break it down into small steps and sub problems and divide and conquer and all that stuff. That's basically composability. Right? And so with composability, we can coordinate and build bigger and bigger systems. I'm just going to make a couple examples. So this is Naraka Play Point. This is the color scheme. This is the interface where you get to edit the face customize the face of your characters, right? So you can move your different parts of your body and your face differently. You can dye your hair differently, customizing your avatar in the games. This can be understood as like game 1.5 maybe. Like you're customizing stuff in the game, right? But you are still using the editors provided by the games. You cannot touch the underlying game code directly. This is the game customizer in Ghost Recon. Again, you are using some editor provided by the games, but you cannot touch the underlying code. This is Roblox, right? So we talk about what UGC and Roblox is a prime example. They provided this Roblox editor for people to create custom virtual worlds and little games. Still, they give you the editor. They expose you with the editor for you to change things, but they don't give you the underlying access. Dog Force. So I think crypto native people would know Dog Force is like the strongest pioneer of on-chain games built on layer 1 sidechain. And their mechanics is essentially Dog Force. So you essentially send energy to other planets to take over and you conquer the universe. And what's special about Dog Force is they have a plugin system. Right? So I can write computer code to automate a bunch of things for me. So I'm essentially running a bot network. I can create bots, I can deploy bots, I can create bots and put on a marketplace so other people can purchase and use my bots and so on. All these bots are automating actions so that people are playing at a higher playing field than what the core game system provides. And all these plugins are created by players. They're not officially provided by the developer. So we are also making games. We're making Isaac at the moment. Isaac is the color is horrible. Isaac is a game about three-body problem. So three-body problem is essentially, imagine a universe where there are three suns, right? Our universe has one sun, and so the Earth revolves around the sun in a safe and a nice way. If you have a solar system with three suns, everything is kind of chaotic, right? The planet can go very close to the sun, it's super hot. It can go very far away from the sun, it's super cold, and it can crash into the sun and everyone dies. So that's a three sun solar system, a tri-solar system. Isaac is a game about this. Documentation and contracts all open source, and we are currently in closed alpha. So this is This is a screenshot for the actual game client. So you have three suns, and you have a planet that travels at a trajectory. Every player lives on the same planet. And so every player either win or die together. It's like a massive co-op PvP. There's no PvP incentive. And the way to avoid civilization destruction is players work together to drive their planets here and there. So imagine you're driving Earth like a car. So you're dodging the sun, and eventually you can escape the solar system. And the way they would do that is they're essentially playing the Factorial game. Factorial is like this factory resource management game on the planet. So this also is a screenshot of the game front end. So people are building these different buildings, and they're generating power, they're harvesting resources, they're transforming resources, and eventually they will build something called the nuclear engine. And when you imagine you install a nuclear rocket on the ground and you launch it, you're essentially kicking the planet in reverse, right? Instead of escaping the planet, if you deploy the rocket on the ground and launch it, you're essentially providing a reverse momentum to the underlying planet. So this is the mechanism through which players drive their planets around like a car. What's special about this Isaac, I think, is that we're the first one that ever runs physics simulation on the blockchain. So this is the very familiar gravitational law, right? The inverse law. The further away you are from me, the less gravitational pull you experience from me. That's Newton's law. And we are simulating this law with the standard numerical method, the fourth order Runge-Kutta method. And we're carrying out this computation in a smart contract on StarkNet. And the reason why we do physics on the blockchain is because imagine you live in a world where the underlying laws of the universe is not guaranteed to be immutable. And some single party can just mutate the laws of the universe. That would be kind of insane. right? But that's actually what all video games are. Game companies can change things arbitrarily when they think they make more money for them, for example. So that was the physics, and this is the on-chain puzzle that we put out last week as like a gating mechanism for accepting closed, open alpha players. So we essentially put a puzzle in StarkNet, and we say there are 50 puzzles, and when you solve one puzzle, you get a ticket to participate in our alpha. And the puzzle's on a chain, so there's no way to cheat, right? It's like when you want to play Isaac, if you haven't already solved the puzzle, then the blockchain will just revert your transaction. You'll get to play the game. So this is the way we kind of filter through the invitees to our alpha. Last thing we want to talk about Isaac is we think governance is very important. DAO is just at its very beginning, still in 2022. We like this idea of infinite game. Infinite game is this idea that you're playing the game not in order to win, you're playing the game in order to play more. Right? It's kind of like if your goal is to retire, then you just earn and retire, and it's just like you just go from 1 to 0. You don't work anymore, you just go retire. So like working for retirement is like a finite game, but working for building more stuff so you can build more, that's an infinite game. And we think it's important to applicate the concept of infinite game. So CarStyle is a governance structure that advocates for infinite games. And what CarStyle is that in order to have governance right, you have to play the game. So the governance right of CarStyle is not earned by, you can't buy the DAO token. The DAO token is earned strictly by playing in the game, and you sell out the game. So players will play the game. If they win the game, the result will be communicated to the DAO, and the DAO will issue voices. And voices can be mapped to votes later. So you can do like plural voting, mapping, and all sorts of exotic voting methods. And the purpose of this is we want the games to be governed not by people who have capital power, but by people that have played the game well and really understand the game. That we think is the sort of the core stakeholder of the game. Finally, these are two StarkNet services that we are using to build Isaac. So Yagi is the ticker. So all video game has this ticker, right? It's like a cloud service taking the game frame by frame. Yagi is the ticker. And Abibara is the system that indexes StarkNet and organizes everything in a nice database so the front end can just talk to the database instead of having to talk to the blockchain. That just improves performance drastically. And finally, we're showing this very early tech demo. So we're making an on-chain fighting game. And so this is an internal tech demo. You have a female character with a katana, and it's like doing forward dash, backward dash, and some attack animation. What's on the blockchain is the physics. Right? So the character accelerating and deaccelerating with the friction, this is on chain. What's also on the blockchain is AI. So this sequence is not driven by me pressing the keyboard and mouse. This movement is driven by very simple AI, where it basically manipulates the input queue. If you play a fighting game, you know what input queue is. So this is a game about AI fighting against each other in a fighting game context, and we are not announcing this title yet. There's a lot to be done here, but I think that this tech demo sort of signals at the massive unrealized potential of making games on StarkNet. So thank you, and happy to answer any questions.
Thank you for your speech, and now we're going to have some session for questions. So is there any questions? I'm going to transfer the microphone. Then I'll read out 2 questions in the YouTube. First question is, why should I learn Cairo if there is already a Solidity translator?
Well, my experience is I don't have much experience in Solidity. I like Cairo because it's a very low-level language, so it gives me full control. And I like to have full control over whatever I program. So that's one reason to learn about Cairo. The second one is I don't think the transpiler will give you the native performance of Cairo. If you were to just learn Cairo, like systems that have high performance, if you rely on translation, there are a lot of language features that are not supported in Solidity, and so there's no way to map from one language to the other. So writing Cairo gives you the best performance, I think.
Thank you. And here is one more question. What What is the secret for topology? What is the secret for topology?
Oh, we don't have to take it. We don't have to token. I think we're really building for the long term. Right? We're speculating game 2.0, and this will basically offend the game industry. And so it's way too early to talk about token.
Thank you. So now we're gonna go to the next section. Thank you for your seat.